Welcome. Today we're going to be taking a look at how we can work with SQL. Specifically, we're talking about the TCL subset and what that means for database land. So TCL stands for the Transaction Control Language. Now, what that means is it's the subset of SQL or Squirrel that's tasked with data permanency, aka we want to make sure you actually save the queries you make and make sure they actually stick inside the database when you're done with them. So we actually have to think about when we want to commit the information to our database, because when we work with SQL, the changes we make aren't actually permanent until we tell it to be permanent. That's something we have to actually consider. It's a little bit different than when we're working with, say, for example, writing code in Java or Swift, so we have to make sure we keep that in mind. We also want to make sure we keep that in mind that there's some actual rules and structures about dealing with permanency of data, because if you make the wrong approach to data permanency, it can cause actual physical money costs, time costs, and emotional costs of when that happens. So keep that in mind whenever you use the idea of data of the transaction control language, because data permanency is not just a wishy-washy thing. You have to actually make changes and deal with it. And the best thing to remember when we're talking about transaction control language is that every transaction itself is pending until the commit itself happens. So it's pending or temporary until commit. So just keep that in mind. The four commands that exist in TCL are commit, rollback, rollback to, and SAVEPOINT. And the actual execution and syntax attached to these keywords is really, really easy. We'll actually go into a lot of details to see how that works as we go through the samples of this lecture today. So the first one we're talking about is SAVEPOINT. So a SAVEPOINT is like a temporary save of the internal state of your database. Kind of like what you might see in, say, for example, in a video game. We have right here an example of a save file from Legend of Zelda. And as you can see right here, I have a map village, a no data, a south of the village, and Tornbow Shores. And so we have a nonlinear sequence of saves. So it's the idea that each of those things represent internal state of the game for that. And that's how the idea of a SAVEPOINT is similar to. Another way we can look at this is the idea of a edit history of a text editor, as long as you don't make any changes, because it is a very linear process. It is sequential, so this thing, then this thing, then this thing, then this thing. So you want to keep that in mind that when we're talking about save points, they are definitely stored in a linear time sequence. It's not wibbly wobbly, timey-wimey stuff like, say, Doctor Who. This is a linear sequence of time travel. Also, one of the things that's really important to keep track of is you can't actually see what your save points are named after you run them. So it's very important that if you use a save point, you keep track of that somewhere besides simply just, right there on this document. Because if you close your console or you're not keeping track of that for some bizarre reason, like, that maybe you hit the a button and you forgot what you're doing, you want to make sure you actually keep track of it, because if you lose that save point, you won't be able to recover that information. There's no way to actually, what did I name that again? You can't pull that back up. And you can roll back to a save point you have up until you've done a commit, but any save point that is after that in that linear sequence, so if you have a save point here, these save points right here no longer exist, and any other changes as well that are after the save point are gone. They're wiped out completely. So it's very different from a video game save. So it's only a temporary linear state-based saving. So it's not quite video game level. It's not quite as cool as that, so just keep that in mind. To use the save point, you just want to use the idea of a snake case notation, so we keep the same common writing that we're working with all of our queries and stuff we've been doing so far. So in this case, I have save point demo code. And don't be afraid to make a bunch. The save point is more like the idea of a GitHub level commit, because you're simply marking out where you currently are at this point. And so it's a great thing you can do regularly and often inside your work when you're talking about adding data or manipulating data inside your actual data structure of your database. So just keep that in mind. Save points are good to use often and keep track of what you're working with. Rollback to is how I work with save points. And so I want to go back to a specified save point. So rollback to and then the save point name. That's all I have to do. And that's how I can specify any single point in my transaction history. And any and all transactions that are after that point, so if I choose this point, all those transactions, the save points and all the modifications, they're all wiped out. Any and all transactions that are before the save point, those are all still there. So you keep that in mind. And when you use the rollback to, the ones that are before that are good. The ones that are after that, wiped out. So keep that in mind as you work with rollback to. The rollback to syntax, really easy. You just specify the name of the rollback of the save point you're rollbacking to, and then everything after that point is gone. So just keep that in mind. Once you roll back to that point, all the subsequent code changes or state changes are all lost from the database. Now the big one, commit. Commit is how you identify a permanent data in the database. And this is not to be done lightly. In the words of Violent Femmes, oh yeah. Yes, as Violent Femme said, it does impress you actually did the commit. However, it's not to be done lightly, because again, like we talked about earlier, if you actually do a commit with your data, that locks it in place. And so all your save point information is totally wiped out. You can't return any of them. All the information, the metadata about that save point, they're gone. And the only way to undo that commit is possibly to reload all your data. That means like creating all the insert statements, all the alter statements, everything you did to do all the work up until that point. The only thing to do is to redo all that work again. Now that is a huge time cost, work cost, mental cost. And so you definitely only want to check with your business, your group, the people you're working with, your partners, when you're talking about doing a commit to the database, because when you run commit, at that point it locks everything in place. And so if it was a lot of work you did, that would, if you made a mistake, that's gonna be a whole bunch of work to undo completely and recreate. So you definitely wanna keep that in mind as you're actually working with that. Because manual recreation of data, that takes a lot of time and effort. And so we wanna avoid that if we don't need to. This is possibly the easiest way to do anything in TCL, simply commit semicolon. All it takes is that. It's also just a button right there inside the actual SQL developer. And so it's really quite easy for syntax to make that happen. So once you do this, you want to make sure you do it only when you need to. Now, one of the nice things about this is when you properly exit SQL Developer, it automatically commits by default. So that commits all the changes to your database when you properly exit SQL Developer. So that means, oh, I did exit, we're good. If you have like a force quit or an in task on that, there's no guarantee that commit happens, so those changes may not actually be saved. So again, when you're looking about making actual permanency to your data, make sure you use that commit appropriately and make sure that when you actually exit the system that happens, because if you didn't exit properly, your changes may not be actually made permanent because you didn't properly exit the structure for that. So keep that in mind, that the commit must be made to make sure you lock your data changes in, but only do that when you need to. Finally, we have rollback. This is the total, just wipe that all out and go all the way back to whatever the previous commit was. It takes away every single DML, aka data manipulation language, and all SAVEPOINT, your TCL statements. Those are completely wiped out. All your transaction history is gone, just like that. And so because commit wipes all that out, that basically just resets all of the changes that were made. And so you want to make sure that if you use a rollback, you make sure you only use that when you're, oh, I want to go back and undo everything I just did. Because it takes everything that has been changed since the last commit and it just wipes it all out. This is not just like an undo, this is a force wipe everything, and you can't recover. You can't just step through it like, again, like you're using your undo history or redo history inside the edit command. This takes everything out and wipes it away. So you only want to use this when it's the only option you have, because you say, for example, you lost your SAVEPOINT names for some bizarre reason. So rollback is the option that, oh, I have to redo everything on this point. So make sure you keep that in mind. It's really easy to do because all you have to type in, again, is just rollback. That's all it takes to actually run that, and it'll wipe everything out going back to the previous commit. And so as we go through this, remember, again, in the words of Violent Femmes,
I hope you know that this will go down on your permanent record. Oh yeah?
so make sure when you're working with TCL or the transaction control language, you keep in mind that this is an important and big deal. And so it will commit. If you do a commit, it locks it in place. If you do a rollback, it wipes it all out. And so I hope that's helpful. Cheers, have a great day. We'll see you next time. Bye-bye.